whatever it is, together to get a final solution. So take a look here. We got a chemist. You can read through it. There's a 10% sodium ion solution, and then there's the 60% type. I got to mix those two together, so I get a 50 milliliters of 30% solution. So how much of the 10 and how much of the 60 do I need? Your head's spinning probably, and I don't blame you. First thing, let x and y equal something, so we know what the heck we're going to answer. So it looks like what's one type of solution I need? Okay, so we'll go, this is the amount of 10% solution that I'm going to need. And what's the other one I'm mixing with it? 60%. So we'll call that y. So there's your two variables. I like to visually see this going on, like literally these solutions mixing together. So what I'm going to show you here, when we do these mixture problems, I'm just going to put buckets here. All right. What's in the first bucket? What type of solution do I need? 10%. So there's a 10% solution in here. How much do I need of it? That's what we're trying to find. So there's bucket one. It's got my 10% solution. I don't know how much is in there. We'll find out eventually. All right, plus bucket two. What's in bucket two? 60%, right? How much do I need of that one? Don't know. That's what we represented a variable. That's your y, right? Boom! Mix those two bad boys together. I'm going to get a final bucket, which has what in it? Keep reading. I mix the two together. 50%. Oh, I'm sorry, 30%. Yes, thank you. I was getting ahead of myself. But unlike these two buckets, we know how much we need. So instead of putting a third variable there, what can I put underneath the 30? How much of that do I need? I need 50 milliliters of this 30% solution. I'm going to put a 50 underneath. So there's visually what we're doing. 10% bucket, mix it together with the 60% bucket, and we're going to get a 30 out. You guys don't see it, but your two equations are up there already. Your two equations are already up there. Here they are. First one. You're taking care of how much you have right now of each. X plus y has to equal how much in the final bucket? There you go. There's equation one. Done. Everyone see where that's coming from? That's just taking care of your amount of solution. Now we apply the percents. 10%, but I don't want to leave it as percent, right? You guys know the deal around here, right? We leave it as a decimal, 0.10 times how much do we have? It's right in the bucket. How much do we have? X plus, not 60, but 0.60. How much do we have? Good so far? Okay, here's where I got to harp on, because I don't know what it's, something in the brain, I guess, malfunctions when we get to this side. It's already in your, do the same exact thing we just did over here. 30%, how do you write it? Don't leave it like that. Times how much you have. How much do I have of the 30%? Guys, that's what I just did over here, right? 10% times how much I have, 60% times how much I have, 30% times how much I have. Now, if you want to go to your calculator and clean that up right there and actually figure out that value, your call, go ahead. I'm going to do that right now. .30 times 50. What do you guys have there so I can clean that up? 15? All right. You can make a whole brand new equation or just erase that and put 15, but know where it came from, though. All right, make sure you make a note for when you're doing the assignment tomorrow. That was 0.30 times how much I had. And, all right, I'm still not confident that we're all confident in solving these. Can I eliminate anything right away? Nope. Cannot eliminate an X or a Y right away, so I'm going to have to, this is the way I do it. I know some of you do it differently. I multiply an equation by one number so they do cancel out. So I'm going to multiply this equation right here. I can multiply it by negative 1.10, right, everybody? Or negative 0.60, your call. All right, it's either eliminate the x's or eliminate the y's. Do we understand that part? Because I know some of us are having issues with that. And that makes me nervous right now. Okay. I'm just going to multiply it by negative 0.10. Distribute it. And again, some of you guys forgot this yesterday. Please distribute that, whatever you're multiplying by, all the way through. And this is where I'm slowing it down now. Negative 0.10x minus 0.10y equals, what's that one, negative 5? Is it negative 5? Okay, x's cancel. See you later. I get a little, I don't know, not with you guys. You guys are pretty good. You've proven to me this year you're pretty good. Some years, though, I get worried when kids have to deal with decimals. Watch what you're typing into your calculator. Take your time. This is what? Positive 0.50 equals 10. I don't know why I put the plus sign there, but. Yep, go ahead, divide both sides by 0.5. If some of you are getting ahead of me, that's fine, but I told you I'm going to take it slow today. So what do we got here, 20? All right, so that means if I go back to my variables, I have 20 milliliters of the 60%. So I got 20 of the 60%. And now how do you find the x value? Plug it in. Probably I'm going to assume you want to plug it into x plus y equals 50, right? If you're really hardcore, I guess you could plug it into the decimal one. I'm not. So x plus 20. And honestly, do I really need to see this? No, because I know you can add to 50. So 30. And we're not good yet. We got another one of these coming up. But hey, look at this right now. Look at it right now. Any questions here? We're going to do another visual one right now with the buckets. Grant.
So when we wrote the equations, the first one was just x plus y equals 50.
Yep, how much we had?
And then
no
the second
percents.
one, why did we multiply it by 50 for the second equation in the last one? We did the 0.3 times 50 equals.
Yeah, because the percent, now I'm writing a second equation where the percents go with how much I have. So we had 10% of x, 60% of y, but now here I had 30% of 50. That's where this came from. Okay, so the percents and how much you have is an equation all by itself.
Okay.
Make sense?
Yeah.
Okay. Anybody else? Good questions. All right, you ready? What are we mixing up next here? Oh, a little tea, huh? Anybody tea drinkers? Anybody coffee drinkers? That's something I never, ever acquired a taste for, was coffee. Nothing. Nope. The taste of it just never got me. Water, milk, orange juice, Powerade. I guess that's about it for me. Maybe some Tito's here and there, but that's daddy's adult beverage, according to my girls. All right. Everyone ready? Ready to go? By the way, what? A teacher can't admit it's Tito's time? I can't. No? All right. If you want to know, 5:30 every Saturday. Don't bother me. All right. My daughters know that's Daddy's Tito's time. And all he wants is a half hour of some damn peace and quiet. So that's what that is. All right. Yeah. There you go. Ready to go? All right, moving on. All right, we learned something about each other every day, huh? Okay, two types of tea. You got your $6 tea and $8 tea. I want to mix those two teas together to make 144 pounds of tea that's worth $7.50. All right, variables first. Variables. What's the first type of tea I need? $6 tea, right? So $6 tea right here for X. For Y, what's the other type? $8 tea. Yep. Again, it's very easy. These problems are much easier for me when I have a visual to see. So what's in bucket one? $6 tea. Do we know how much we have? Well, X, right? We have X amount of X pounds. All right, add it to bucket two, which has what in it? All that $8 tea, the high-end stuff. Equal to Y. Shake them up, mix them together. Final bucket has what in it? I want $7.50 tea. Oh, we know how much we have here and here. How much do we have? A ton. 144 pounds. That's a lot of tea. Yes, sir. Yeah. All right, you ready for the two equations? First one, how much tea in total? Without the money applied. How much $6 plus how much $8? I have 144 pounds total. There's your first equation. Now apply your money. No decimals on this one, right? No decimals needed. 6x plus 8y. Now be careful over here. What's on the other side? 7.50 times 144. Yep. Stick with the pattern, right? Stick with the pattern. The money times how much you have. Money times how much you have. Money times how much you have. What is 750 times $1.44? 1,080. All right, so I'll replace that with 1,080. As long as you guys remember where that came from. You think you can go ahead and try to finish this on your own here? You can multiply the top by -6 or -8. Whatever floats your boat. Remember to distribute all the way. What is that number there? Oops. $108 pounds of the high-end tea. Which would mean if I need 144 pounds total, making sure we're getting 36 pounds of the $6 tea. Questions? Mixture. We okay? Mixture. We got a different type of question coming up now. Everyone all right mixing it together? All right, second type of equation here today, motion problems. Motion. Oh wow, we got a plane with the wind, can go that distance in that much time. And then against the wind, same distance, but in 5 hours. Now I use this word velocity, that's just speed. All right, I want you guys to help me find the plane speed and the speed of the wind. Okay, that's what velocity, the speed. I told you guys, I think it was the first day we did this on Friday. I always like to stick with X and Y because you can check it in your calculator like that. I just played around with the calculator earlier today. You can put in any variables you want. All right, so we don't need to keep it to X and Y. And I tell you that because I'm going to change my variables here to P. I'm going to put P for plane speed here. It just helps me out. I don't know about you. If you guys want to keep X and Y, that's fine. I'm going to have P for plane speed and W for wind speed. But if you guys want to keep X and Y, you can. But even if you do check it in NumWorks, you can plug P and W into equations and it'll come out and say P equals this, W equals this. All right, when we do these motion problems, we're going to be using a formula, a very simple formula. Maybe some of you guys have heard about it before, maybe in a science class, I don't know. Distance equals the rate multiplied by your time. Some people call it dirt. All right, distance equals rate times time. All right, so let's do that. I'm going to go slow here because I know everyone's brand new to this. Let's talk about when it goes with the wind. What's the distance when it goes with the wind?
3 hours.
4.
Distance? Okay. Help her out over there, Kate. Christ. So 450 equals rate times time. Now tell me the time. How long does it take to go 450?
3 hours.
Okay, so equals 3 times. Now let's talk about the rate. It's going with the wind, right? So the wind and the plane are both going in the same direction. All right, agreed? So when they go with the wind, the rate is going to be those two speeds added together. Because I'm going with the wind, so they're working together, not against each other. They're working together. So that's why I'm adding the speeds together. So distance equals rate times time. It's going to be the same thing for going against, except for one little change. Airplane flies in the opposite direction. What's the distance? Guys, you're killing me. What's the distance? 450 still, because it said same distance. Fresh cut over there, by the way?
Yeah.
Professional or homegrown?
What does that mean?
Professional, obviously you go and get it done, or homegrown, you get it yourself.
Professional.
Okay. Do you get full say in how it's cut?
Most.
What do you mean? What's most?
My mom will pitch in. She'll throw some ideas out.
Okay. Are you happy with your?
I think it'll look good in a week.
There you go.
A week? You better hope by graduation.
That's bad. All right.
Yeah, it's good.
I'm gonna come at
It's better than it was, right?
I'm gonna come at you.
It was like you had squirrels and beavers living in that thing, but now I could just see like very, very small woodland animals might be hibernating in there, but it's all right. It's all right. I was going to ask if you do any gel or anything, but I think I know the answer to that. All right. I'm never going to live that one down, am I? But it's fine, Drew. Do you approve?
Yeah.
Okay, and that's all that matters. Can I ask, what do you ask when he says, what can I do for you?
What, you want it? Like, I don't know.
No, like, how do you want your, like, you got to tell them,
Yeah.
like,
I show
do you
him a picture.
trim blades?
Show him a picture.
Okay,
Oh my god, it's like getting your nails done.
okay, I got you.
I didn't realize they did.
That was the first I've ever heard, show them a picture.
What?
No?
Well, crap.
Are
you serious, Grant?
What do you say, Grant?
Grant said I don't do that.
The lady just say so.
And you don't have any say, you're just like, do whatever you want.
Nope, it just buzzes it.
All right. All right. Nice. All right. Thanks, Drew. All right, going back to our little problem here. Now we go against the wind. Now it doesn't take us 3 hours. What is it? Now it takes us 5 hours. And here's where the change up's going to come. Now you're working against each other. All right, against each other. So you're not going to add the speeds because you're not in the same, you're going against each other. So now it's plane minus the wind speed. All right, because you have to subtract off the speed with the wind because you're going against each other. So the plane's not going as fast. All right, I debated today how I was going to show you how to solve this because there's a trick you could do, or we could do it old school and distribute the 3, multiply both sides by whatever you need to, and get rid of a variable. But I was like, you know what? These kids are pretty good. All right, this is a rare year where I get a class full of ability, some of us. So I'm going to show you a little quick trick. All right, that makes this go a little easier than just, because here you go, ready? You decide, but you could do this, right? Distribute the 3. Just let me show this real quick. And then you could distribute the 5. Multiply each equation by a number so you can cancel them out, right? That'd take a while, but it would get the job done. Instead, here's what I'm going to show you. Get rid of the 3. How do I get rid of the 3? Divide both sides by 3. Go ahead. Divide both sides by 3. Now what do I get? What's that over on that side? 150? So watch. I get 150 equals what's on the right side still after I divide it by 3? P plus W. And then on this equation, get rid of the 5 before you even start. Divide both sides by 5. Now what am I looking at? Is that 90? 90 equals?
It's not 50, it's not.
What? It's 90.
90 equals P minus W. Why do I suggest doing this? Now look at what we have. What cancels now? See you later. W's are gone. Whoa. Yeah, the W's are gone, but you're not left with P. 2P, right? Be careful there. If you're going to do P plus P, no?
Yeah.
1 plus 1?
Oh, yeah.
We good? We're sure? We're good? Okay. That's why I go over it. And then over here we have what? 240?
Oh, wait. Let's subtract.
Right, they're both positive. They're both positive. So the plane speed, 120. Now again, this is just a shortcut. If any of you are uncomfortable or you know you're going to make mistakes, I highly recommend distributing the 3 and the 5 and going up here. Okay, you're still going to get the same answer. All right, P equals 120. How do I find the wind speed now? Plug it back in. Okay, plug it back in. Well, where do I plug it back in? I can go back over here, right? I could go over here and plug in 120. So if I plug in 120 anywhere, there's a P. We should have a wind speed of what here? 30. Yep. Any other questions there? We got one more. Please, I'm begging you, do what you're comfortable with. If you don't like my divide by 3, divide by 5 because you think you're going to make a mistake, then do it up top and distribute. All right. There's only so many motion type problems I can give you. One is plane speed, and the other is rowing a boat. All right, that's really the only 2 types of motion problems I could give you. So this one is motion, and it says with the current, which means with the water, you can row 24 miles in 3 hours. Against the water, the current, you can only row 2/3 of this distance in 4 hours. Find the rowing speed and the speed of the water. All right, so you guys, I'm going to do R for rowing speed. And wait, W. I don't like to put current speed because that doesn't sound grammatically correct. So I'm going to put water speed. But just please know water is the same as the current. And just a reminder, distance equals rate times time. All right, let's go with the current now. With the current, what's my distance? 25 or 25, 24, right? How long does it take me? What's my time? 3 hours. Now, what's my rate? What's going to go in there with the current? Just like I went with the wind in the previous problem. They're going together. They're going together, right? So rowing plus the water. Done. There's number one. Next one. Be careful here. It's not 24 again. Right? Against the current, it's not 24. It says it's 2/3 of that. So I got to do 2/3 of 24, which gives me 16. It's not always going to be the same. Depends what the problem involves. So that's 2/3 times 24. How long does it take me to do that? So I put my 4 there. And now in parentheses, when you go against it, I got to subtract the 2 speeds. You want to distribute the 3 and the 4 and go from there, that's fine. I'm going to keep showing you my method, which is get rid of the 3. Divide both sides by 3, I get a 8 equals. Am I going too fast there? Is that all right? How we're getting 8. All right. Divide by 4 now. And get 4 equals R minus W. And the sole reason I like doing this method is they cancel immediately. Okay. In this case, the W's cancel. And my fear is, though, you're going to leave it R. That's my fear. But you have 2 of them, so 2R. And then R equals 6. Plug it back into any one of the 4 equations you built. And W will be 2. So you can row 6 miles an hour and the water's going 2 miles an hour. Tomorrow, you'll do your assignment, show me like you usually do. It'll probably take 15 minutes. And then I will hand you the review, which is everything we've done so far.